I anticipate that you guys would have read in detail through whatever module you're busy with, and try to understand the definition of things, and do some problem solving after maybe some explanation in the study guide. Then you attempt some of the problems and see how far your understanding goes. So it's just a question of practicing reading and practicing reading and practicing. You getting your hands dirty. Okay, there's no point in reading and you don't really attempt the problems. It's a futile exercise. So so you guys are free then to pose a question or pose questions, and then I'll try my best to give you solid feedback on that. Okay, or just guide you through a problem, what to think about. Okay, guys. Now the binomial theorem. Basically, bi means 2, so you have the sum of 2 terms raised to some exponent, okay? And then the classical formula, and there are many ways to write this formula. You can write it in terms of n combination r, those coefficients, or you can just write it as follows. And this is a nice, easier way to write it: a to the n plus n, a to the n minus 1 times b, okay, plus n times n minus 1 divided by 2 factorial. We know what 2 factorial means. I'll just explain it quickly. N minus 2 b squared plus, and you can go on in that fashion, n minus 1, n minus 2 divided by 3 factorial multiplied by a to the n minus 3 times b cubed plus, and then there are some terms there in the middle, and plus b to the n, okay? Plus b to the n. So those 3 dots, as you guys would have seen with your interaction with maths, those 3 dots indicate that there are some more terms in between there, okay? Depending, of course, how big your n is. So just remember, guys, if n is a fraction or n is a negative exponent, then there you have to sum over an infinite number of terms, okay? But for the finite case, so in this case, n is an integer here, is positive integer, okay? So n is an element of the natural numbers, right, in this case, okay? If n is a negative exponent, or just a negative integer for a negative fraction, sorry, or just a fraction for that matter, a negative fraction, or a negative integer, then the number of terms that you see in front there will be an infinite number of terms. So you have to sum over an infinite number of terms, okay? Right. So let me just look at maybe one particular problem from the learning guide, just to see how you apply that, okay? Let's consider this one here. So let's consider, there's an example 6 from your book, which I'll discuss with you, and I'll just run over some of these examples. So suppose they want from you, let's say, okay, that one refers to other things. Let's refer to one of the simpler examples here. So the example that I will look at, maybe I should just show it on the screen also, but it's example 2 on page 5, okay? So let me just write down example 2, page 5, okay? It's page 5. So there you have, they want you to expand, they say expand. They say expand a plus b to the 5, right? And then the other one, they also want you to expand a minus b to the 4. Now, of course, with the tools that we had from school, and maybe, yeah, say from school largely, we can multiply this out, but it's going to be a tedious exercise, okay? So what we'll rather do is we will use the binomial expansion here, okay? And here it's easy. We have our a and b already. We have our a and our b. And our n now, this n is equal to 5. It's my n, okay? So we'll just apply this formula straight away now, okay? So that this is how we go about it. So it's a to the n, and n is equal to 5, so it's 5. A to the n minus 1, so it's 5 minus 1 is 4. B to the 1 plus, okay? Right, so that's my second term. Then it's 5 times 5 minus 1, which is 4. And 2 factorial is 2. So you guys would know that if I say n factorial, for example, this would mean n times n minus 1 times n minus 2 times 1. Okay, so that's how you do that. So this is basically an arrangement of n objects. And how many ways can you arrange n objects? So 2 objects can be arranged in 2 ways. Okay, this is what this means. And then it's a to the 5 minus 2, which is 3, and then b squared. Okay, right. And then my next one, it's 5 times 4 times 3. 3 factorial is just 3 times 2 times 1, which is equal to 6. And then my a is there, so it's 2 and b cubed plus. Now we go on, okay? Now the next one after this, there's some more terms in between there. There's some more terms there. So it will be 5. So it will be n minus 1, n minus 2, n minus 3. So it's 5 times 4 times 3 times 2 over 4 factorial, which is 24, which is 4 times 3 times 2 times 1, it's 24. And then my a becomes now, did I miss something here? So it's n minus 4, so it's a and b to the 4, right? And then my last term, well, this will just be b to the n. So it's b to the 5, okay? Plus b to the 5. And then when you write out all these, now, you have all these ones. Sorry, n was 5 here. You just erase that. I wrote n instead of 5. N was 5. Okay, so n was 5 there. So you have to write it as follows. So it's a to the 5, 5a to the 4 times b, and then 2 divides into 4 2 times. 2 times 5 is 10, a cubed, b squared. And looking at this one here, well, we have that is equal to 10, 5 times 4 times 3. 60 divided by 6 is 10, a squared, b cubed. And then this here, what we have here, well, we have 4 times 3 times 2 is 24. 24 cancels 24. I'm left with 5. You guys can just double check there for me. 5, okay. And then I've got a, b to the 4. And then my final term is this one here, b to the 5. That's basically how we do that problem. You guys must just verify. And you'll see a kind of symmetry emerging where you'll see the 10 appearing there as coefficient, the 5 appears there as a coefficient. And then the coefficient of the b to the 5 and the a to the 5 is 1. Okay, there's a 1 in front there. So you see that kind of symmetry. And you'll also notice that the sum of the exponents is 5. B to the 1, a to the 4. The sum of the exponents equate to 5. Okay, a to the 1 plus 4 is 5, b to the 5, a to the 5. So that's what you note from there. So if you were to consider this other simple case, so a minus b, sorry, to the 5, it goes about in exactly the same fashion. However, what you will do here, you will just say a plus minus b to the 5. And you do the problem exactly the same, in exactly the same way as I did the previous one. Okay, so instead of b, you'll have negative b now. n still remains 5, a remains a, but b becomes negative b. So then you'll just do that kind of replacement. Okay, so let me just check if there are any questions for clarification. I trust that you guys can hear me, okay? Osprem, can you hear me? Guys, can you hear me?
Yes, we can hear you.
Okay, great.
Yes, we can.
Great, great. Thanks for that, guys. Okay, so were there any? So can I check with you guys? Were there any questions? Because those were relatively simple problems that I just did now. Were there any problems relating to the binomial theorem which you guys found relatively challenging? Then we can look at that. Were there any such problems, guys? Or were you guys fine with that section? Okay.
Can I ask something? If they decide to put maybe to the power of 20,
okay,
will I write the steps until to the power of 20?
Yes, but fortunately they won't ask you that. That would be very evil of them to ask you to do it to 20. Okay, that won't be nice. Really, that won't be. I wouldn't be happy with them if they do that, because it's just a repetition of things. I mean, they don't achieve anything in terms. You don't achieve anything in terms of learning if they ask you that. Because the process is just the same, you know. So they can ask you maybe, what is the fourth term? You know, there's an equation for that kind of thing also. What is the fourth term? What is that? You know, yeah. So that's another matter. And you'll see, guys, that in the case, let me just make one more remark. In the case where n was equal to 5, you had the sum of 1, 2, 3, 4, 5, 6 terms. So if n is equal to, let's say, 6, you'll have the sum of 7 terms, and so forth and so forth. Of course, when n is a fraction, negative or positive, or n is a negative integer, you'll have the sum of an infinite number of terms, okay? But normally in such cases, they will ask you maybe to write down the first 3 terms, or maybe write down the 5th term or something, or the 6th term or something, okay? Especially in cases where n is a negative fraction or positive fraction, or n is a negative integer, okay? Right. Okay, cool. Any other questions for clarification, guys? So definitely, if they were to ask you that up to n equal to 20, it's just a grind. It would be silly for them to ask that. Okay, I personally will never ask something. I've never asked something like that. Okay, right. Any other questions, guys, that you battled with, maybe that we can look at, maybe from the activities or from some question paper, perhaps? Can I just check with the people, Yashmaya? I just wanted to see, Ms. Pram, in the absence of a study guide, I just wanted to check by when they submitted assignments. Have they submitted assignments? And were there any problems maybe that they encountered in the assignment? Do they want us to look at? I don't know how far they are with the assignments.
Students, please feel free to engage with Dr. CS. You can unmute your mic, please.
Zippo, can I ask you how far you guys with the assignments? Edwin, have you guys attempted any assignments? Are you done with that? Dolphus, how far you guys with the assignments? Okay. It's Franz, no? Franz. Okay, Franz has a question there.
Yes.
Okay, Franz.
Is it possible for us to do an example with a fraction?
Yes, there is such a case. Do you have something in mind, or should I construct such a problem?
You can construct such a problem.
Okay, because they go the same. Once you know one, you know all of them. Okay.
Yes.
So let me just check. Can you guys see the whiteboard there? Can you guys see the whiteboard?
Yes, we can see it.
Great. Okay, great. So so let me call this also an example that I just constructed. So suppose they ask you a question like this. So this is an example that I just constructed now. So they say you must use the binomial theorem, or use the binomial expansion, or use the binomial theorem to expand the following. So suppose they say x plus y, let's say let me make it more, a little bit more hostile. So suppose they say to you, yeah, okay. Or maybe they say this to you, or let's say they say this to you. So you have to expand this using the binomial theorem. They say this to you. And they say maybe write down the first 3 terms or something like that, okay? Or write down the 4th term or whatever. They can ask you those kinds of questions. There are 4 little formulas for the nth term or the rth term. There are such formulas in your guides. So let's consider maybe this one. Let's consider this case. So suppose they ask me maybe to write down the first 3 terms, okay? Let's try the first 3 terms. So let's do that. Let me just erase this one here, because we know how we will write this one. This one is x plus y to the half. This one that I'm erasing here is just x plus y to a half, okay? And here I wrote down this incorrectly. I should have written the cube root of x plus y. So suppose they ask you to use the binomial theorem, and you must expand, and they must write down 3 terms. So here in this example, they ask you to write down, say, the first 3 terms for the cube root of x plus y. So what you will note first is that x plus y in exponential form, from your early experience, you know that x plus y can be raised to the exponent a third. That is exactly the same statement, okay? Right. So we consider this now. We'll expand this and we'll use that formula. Let me write down the formula again. So remember, so just recall. So this is what we have. So recall that a plus b to the n can be written as a to the n plus, so we'll just revert to that formula, n a n minus 1 b plus, remember, I'm just writing down the first 3 terms, okay? Because we just have to deal with the first 3 terms. So n minus 1 over 2 factorial, and then a n minus 2b squared. Right? Of course, we know this goes on for n equal to a third. We know that this goes on up to infinity. The number of terms go up to infinity. So those 3 dots denoting that we have to add an infinite number of terms. We are interested, for my question, saying we want to expand up to 3 terms. To 3 terms, okay? We must write down 3 terms. But we know, of course, for n a third, we have the sum of an infinite number of terms, okay? So you guys must just make sure that I wrote down this correctly there. So let's see quickly. So we've got n, for our case, n is equal to a third. We've got x is equal to a, and y is equal to b. So we just have to apply the formula. So therefore, we have x plus y to a third equal to, remember, x is equal to a, so it's x to a third. So remember, I wrote the third form, I wrote it into exponential form now, okay? So that makes it easier. So there's my a is equal to x. My n is a third. We have identified n is a third, so it's a third. X is equal to a, and it's a third minus 1. And b, our b happens to be y times y. There's it. Okay, our problem here, our problem. Those are 2 terms, right? Plus n is a third, n minus 1 over 2 factorial, which is just 2 times 1, which is 2, times a, which is x, and n is a third, minus 2, and y is b, and now that must be squared, okay? That must be squared. Right. And there are my 3 terms. But we know, of course, this is the sum of an infinite number of terms. So I've got currently 3 terms. Let me write them out and see what we have. So in the case where n is a where we had to find the cube root of that sum. The cube root of that sum, well, and we're writing down the first three terms. This is how it will go about. How we'll go about. So x, you guys know that a third minus 1. What is a third minus 1, guys? Minus 2/3, right? Times y plus. Right. Now a third times minus 2/3. This product here, what do we have here? Anyone wants to venture an answer there, guys? So a third minus 2/3 is minus 2/9, right? All divided by 2. And this is a third minus 2. Now, what is a third minus 2? A third minus 2, guys. Anyone wants to venture an answer there? A third minus 2, guys? Anyone? Minus 5/3, right? Y squared plus, there are my 3 dots. And now we can simplify further. And we can write this as follows. X to a third, sorry. X to a third plus a third. X to the minus 2/3. Y. And now here I can drop that 9 that's in the denominator of the number in the numerator. We can just write it as minus 2. 9 times 2 is 18. So we drop that 9 to multiply by 2. X to the minus 5/3. Y squared plus. And of course, we can simplify this further here. This is just minus 1/9. Okay, so that in the final analysis, your answer, where you had to expand up to 3 terms, is just this. There's it, guys. Okay, 3 dots, denoting that the number of terms go to infinity. Okay, you have to add up an infinite number of terms. So that was the case where we had a question. It was the case where we had this kind of question, where they ask you to use the binomial theorem and to expand and just up to 3 terms, the cube root of x plus y, which we wrote in exponential form as x plus y to a third. We identified n as a third is equal to a third. X equates to a and y equates to b. And we could expand it up to 3 terms, okay? Of course, bearing in mind that the number of terms that we have to add are an infinite number of terms, okay? Right. So you guys can just double check that if you're happy with that. Who asked that question? Was it Frans? Huh? Okay, Frans.
Yes.
Frans, does that address your question?
Yes.
Okay. So with adding fractions and multiplying fractions, I know some people are lost without a calculator, but sometimes you must learn to do these things without calculators, okay? You can do it in your head, many of these things, okay? It saves you time, ultimately. Right, so thanks for that question, Frans. Ngelechedzo, Oswald, Udzanani. Any questions there, Oswald?
No, I have no questions.
Okay, good. Okay, the name sounded very interesting. That's why I asked you. Okay, right. Tabo, any questions there, Tabo? Bongiwe, any questions? Okay. Right. Let's do maybe one last example then. Let's just do one last example. If there No specific questions? Okay, let's just do one more example. Tavo, did you have a question?
Hi, sir.
Hi, Slindile, eh?
Yeah.
Okay,
Can we do
Slindile.
one? Sorry. Can we do
Okay.
one binomial theorem from
Okay.
assignment 1? Sorry, I'm walking.
Okay. Can I first check with you? I first want to check before I agree to that. I don't mind doing that. But can I establish whether the assignments have been submitted and what was the due date? What was the due date for the assignment before I do that?
It was recently uploaded. I think
It was what?
due recently uploaded.
What
think
the
it's
solutions?
posted
The
now.
solutions?
No,
The
not the
solution.
solutions. I'm
The
just saying
question.
the assignment. Yes, yes.
Is it okay? Then what I'll do is I won't solve it for you. I'll just try and guide you through the problem. Is that okay? Is that fine?
Okay.
Okay, great. So Ms. Pram, I just want you to bear witness that I'm just guiding. I'm not solving the problem. Okay. Otherwise, it will be unethical. Okay, for me to solve the problem for you. So okay. Now that's fine. Slindile, can you see the whiteboard there?
Let me check. Sorry.
Can you see the whiteboard?
Yes, I do.
Okay, great. So what I'll call this thing, let me just call it a question, okay? And then I'll just guide you on it. So it's a question that's posed. It's just to guide you, okay? So what is the exact question saying? Because I don't have that tutorial later. What is the exact question saying?
It says use the binomial theorem to
Okay,
expand.
just for the benefit of everyone, use the binomial theorem, okay? People listen, when you write in exam, don't say BT, okay? Please don't say that unless you've defined it somewhere. So I'm saying use the binomial theorem. I'm saying BT because just to save time, okay? Use the binomial theorem to
expand. Open bracket 2x minus 3y, close bracket to the power of 4.
Okay, open bracket, you're saying 2x?
X minus 3y.
X minus 3y. Okay.
Close brackets to the power of 4.
To the exponent 4, right?
And simplify each term.
And simplify each term, okay. And simplify each term. Well, simplify each term. There's my I there. Simplify each term. Was that all, ne? Was that all it asked?
Yes. Yes.
Okay. So maybe what I'll do is I'll write down a couple of terms. Then in total, there are 5 terms that will come from there because for the number of terms, you just add 1 there, okay? When n is an integer, a positive integer, okay? So in this case, I must identify my n, my a and my b. In this case, so happens that a is equal to x, b is equal to minus 3y, and n equates to 4. So there'll be 5 terms arising from there. So we'll revert to this formula here. We'll revert to this formula. I'll write down maybe I'll write down 3 terms and maybe I'll help you with 3 terms. You can do the remainder. Okay. So I'm referring to this now, but in our case, of course, there'll be a finite number of terms, right? The number of terms, like I said, will be 4 plus 1, which will be 5 terms. So I'll help you up to the 3rd term. So I'll do this up to term number 3, okay? And you can just from there figure out the other 2 terms. Is that okay with you, Slindile?
Noted, sir.
Sorry?
Yes, it's okay.
Okay, great. Okay, so I will leave it up to you to your imaginings how you resolve this. So just to again stress that a plus b to the n is equal to a to the n plus n a n minus 1b plus n times n minus 1 over 2 factorial, which is just 2. Okay. A n minus 2b squared. So I'm going to write down 3 terms, and then I'm going to say plus, and then you will fill in the other 2 terms. Well, I'll write down the last term for you also. I'll write down the last term for you, plus, and the last term will be b to the n. So you just have to fill in this term here where the 3 dots are. There's 1 term missing from what I'm going to do. Okay, but I'll do the 3 terms. I'll do this term, I'll do that term, and I'll do that term with you. Okay, that term there, I'll do that. So I'll do 3 terms with you. Okay, that one and that one. So let's see. We have identified A, we have identified B, we have identified N, and we know the number of terms should be 5. So I'll do it up to 3 terms. Let's see now. So we've got X. So N is equal to 4. So I've got X to the 4. And my A is X plus N. N is 4. A is X. And that is N minus 1. It's the exponent N minus 1. So it's 4 minus 1. Just taking my time a bit here. And B is equal to negative 3y. There's my B, negative 3y. Okay, there's my B. Okay, then my third term, it's n times n minus 1, which is 4 times 3 over 2 factorial, which is 2. My A is X, so it's X to the 4 minus 2. I'm here now. And then B squared, which is minus 3y all squared, plus. Now I want you to fill in that term, and then you have to fill in that one there, the 4th term. The 5th term will be minus 3y. This is my b to the n, the exponent 4. That's what you'll have there. So I want you, where that arrow points downward, you need to fill in that term, okay? Because in total there should be 5 terms. I'm going to write down, let's say, I will write down 4 terms for you. It's okay, then I haven't solved everything for you. So let's simplify now. So it's x to the exponent 4. Then I've got 4 times negative 3 is negative 12. It's x cubed. And then I've got y. Right? And then here, I've got 4 times 3 is 12 divided by 2 is 6. Then I've got x squared, because 4 minus 2 is 2. And then I've got negative 3 squared, which is 9. 9y squared. And this term I leave for you there to fill in that term. And then my last term is minus 3 to the 4, which is just 81 y to the 4. And then so all the other 4 terms are these now, according to my calculation. Plus, this is the one that you need to fill in there, put a question mark there, plus 81y to the 4. So, Slindile, that's where I will leave you, and I trust that you follow that. I've just put a question mark there because I wanted you to put the term in between the last term and this term 54xy squared. Okay. I think that's a fair. Do you understand what I've done there?
Yes.
And my supposition is that you understand the expectation from you now to establish what that term is there between the last one and the one just before the term you require, right? Okay. Because
Hi, Sam. I have a question.
Okay, let me just before you proceed. So Slindile, you'll be able to do that now, right? You'll be able to do that. Is that okay?
Yes, sir.
There's that term missing. Okay, and that term is n times n minus 1 times n minus 2 divided by 3 factorial times x to the n minus 3 y to the 3. Okay, and then you're done. And then you simplify them. That's what they want. That's why I simplify those coefficients and stuff. Okay, right. Great. Thanks for that question. So someone asked me something. Who's that? Is it Matsatsi? No?
Yes,
Carol.
sir.
Okay, Carol. What was your question, Carol?
On term 2, you have 4x to the power of 4 minus 1, right?
In term 2, yeah, yes, yeah.
Yes. And then on term
Term 3?
4, the
Term
next
4, term 4, I've got nothing. I don't have a term 4.
the other term 5.
Term 5, yeah, is the last term there.
Yes.
It's this term here. It's this one here. P to the
you
N.
you have that term in a bracket.
Yeah.
So
Minus
now
3y.
you're, yes, then that's why you got 81. You said 3 to the power negative 4, right?
I said negative 3 to the positive 4.
Yes.
Yeah.
To the power.
To the
4.
exponent 4, yeah.
Yes.
Yeah.
Why are we not doing the same on term 2? You close the bracket and then you put, so that this
Term
3
2.
is,
Okay. Okay, so you're talking about this one here? Talking about this one here?
yes, but
Okay.
4x to the power 3.
Yeah.
This
4
3
times, but 4 times minus 3 is minus 12, right? 4 times minus 3 is minus 12. Okay.
So this is 4 times x.
4, yeah. But now I must look at
okay.
those constants, those constant coefficients. I must multiply them out.
Yeah, I understand now. I understand.
You understand?
Yeah.
Are you covered? Are you covered with
Yes.
that? Okay, great. Okay. People, I say thanks for that, Matsatsi. People, are there any? I appreciate the question because maybe it's my handwriting, but you should ask a question, yeah. But I think she's covered now. I clarified that because I'm just multiplying all the coefficients, right? Multiplying all the coefficients there. It's like in this case here, minus 3 squared is 9. 9 times 12 here is 108, and 108 divided by 2 is 54. Okay, so I get that, or just 6 times 9. Okay, right. So you have to simplify those coefficients as far as possible, and then take care of the negatives if it's raised to some exponent. Okay, right. Thanks for that question. Right. Matsatsi, I see your hand is still up. Is that by default?
That's the old hand. Sorry.
Okay, that's the old end. Okay, are there any new ends? Okay, there's a new end here without a name.
Hi.
Hi, who is that?
Mpumi. Sorry, man. It does have a name. It's my other name. So it's Mpumi.
Okay, so is it Mpufu? Okay, let me say that Mfukwa.
Yes.
No Mpumelelo, ne? No Mpumelelo. Okay.
Good question. I see you did term 1, term 2, term 3, and the last term 5.
Yes.
Should we write it this way or should we write it in steps?
Look, you can. I know what you referred to.
Yeah.
It's entirely up to you. You can say term 1. You maybe first do your calculation. Term 1.
Yeah.
Is equal to x to the 4. And term 2. It's entirely your choice. I just wanted to be brief as brief as possible. Okay.
All right.
Then term 2 is 4x cubed times minus 3y, and then you say minus 12x cubed y. You understand it?
That's what I did. So now
No,
that
that's
you're
not
writing,
a problem. That's not a problem. It's not a problem. Okay.
all right.
But then of course, let me just say something there again before I proceed. And of course, in the final analysis, you write it like this because it's a sum, right?
Yes.
It's a sum.
Yes.
And of course, because I didn't want to be ethically implicated for being non-ethical. So I left this open here, okay? You must fill that line, okay? Right, the fourth.
Yeah.
Great.
No, that's not a problem. I just wanted to know how we should write it.
Okay, no. Your method, or let me say your approach, it's totally fine. It's just in the final analysis, you must make sure you write it down as it's sum, okay? Yeah.
Yes.
I think you also reduce the error there arising that you can investigate those terms nicely. But I should be knowledgeable on this because by virtue of experience, I should be able to write it like that now, okay?
Okay.
Right.
No
Okay,
problem.
sure.
Thank you so much.
Okay, no problem. Then there was someone else with a question.
It's Matsatsi.
Okay, Matsatsi, okay.
I saw few question papers. Sometimes they do state the instruction to write in terms. If they don't state, then they said it's optional. You can use the method that you want. I'm not
Okay,
sure.
okay. As long as the method is mathematically acceptable, right?
Yes.
Yeah. Okay. No, that's not a problem. It's entirely up to you. So great. Thanks for that, Mutsatsi, for that observation.
Thank you,
So,
Matt.
okay. So any other questions, guys? Okay, why is my pen getting stuck now? Any other questions there, guys?
Yeah, hi again.
Okay, now it's fine.
Sorry, I'm not sure how far you can go into the assignment, but also I'm not sure if my English is this good, but question 2, there's something wrong here.
Is it
I
okay?
really do not understand what they mean.
No, I think it's not a problem. I'll guide you like I guide the previous person. That's not a problem.
I just want to know what it means. You don't have to do it in steps, but you can if you don't mind.
Okay. Let me just, you know what? I don't know why my pen is getting stuck now. I'm begging to get it unstuck. So, right, okay. Maybe you can just give me the question then, okay?
So it says expand.
Expand. Okay.
1 over.
1 over.
Open bracket.
You know what? I'm just so out of this now. Let me see quickly. I don't know what happened here. Expand. Sorry for that, guys. I think I've recovered. I hope I've recovered. No, let me guide you on it, and then maybe you can understand better. Expand. Okay.
1 over.
1 over.
Open bracket.
Okay.
1 plus x. Close bracket.
Right.
To the power 3.
The exponent 3.
As far as the term in x to the power 3.
As far as
the term in x to the power 3.
As far as the term in x cubed. Oh, okay. Yes. Okay. No, that's fine. That's okay. Of course. Was that the question? Was that
yes, that's what I don't understand.
Okay, no problem. Okay, this is what I'm going to say to you. So they say expand 1 divided by 1 plus x all cubed in the denominator, yes, as far as the term in x cubed. Okay.
And binomial theorem, ne?
Yeah, by using the binomial theorem, of course, guys. So here you use the binomial theorem. And I'm just going to write my own shorthand for it, binomial theorem. Okay, don't follow my example, guys. Okay.
No.
Right. Okay. So to start off, you will first write 1 divided by 1 plus x cubed as 1 plus x to the negative 3. Do you agree with that?
Yes.
Do you agree with that? Okay.
Yes, I agree with that.
And just to remind you, I said from the onset, if an exponent is negative or in fractional form, the number of terms that you have to add are infinite. There's an infinite number of terms, right? Mm-hmm. Right? So, but here, it's okay. You just have to identify A from the formula. Mm-hmm. B is equal to x and n is equal to negative 3. Can you see that?
Yes.
Okay. Great. Okay. And now you just have to invoke that formula of the binomial theorem. You know, that same formula that we wrote on top. And then, which I'm referring to this formula here.
Yes.
Of course, now we'll have an infinite number of terms, but you will stop wherever you see there's x cubed, then you stop there.
Okay.
That's basically that. So you'll do your expansion according to this formula. Yeah.
Yes.
You do the expansion, right? Bearing in mind there's an infinite number of terms. But then they tell you, so what you'll do is you'll write down term 1, term 2, what term, I don't know up to where x cubed will arise. Let's
Yes.
say the x cube came there. Then you write it like, you write all those terms, you'll say 1 plus x to the minus 3 is equal to, then you got your terms, blah, 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 something x cubed. Then you just say that, because there's an infinite number of terms. Okay.
Okay.
That's all. That's all. So
All
I
right.
think that you should be okay now.
Yeah, I'm all right.
Yeah, just invoke the binomial theorem. A plus b to the n is a to the n plus n a n minus 1 times b plus n times n minus 1 over 2 factorial a to the n minus 2 b squared. And then when you see x cube arising, you stop there. And then you say plus dot, 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 showing that you know that in the event where n is a negative integer, there's an infinite number of terms. Of course, the requirement is you stop at x cube. Okay, great. Okay, good.
All right. Thank you
Okay.
so much.
No problem. No problem. Okay, that was a good question, guys. Anyone has got questions beyond the binomial theorem, perhaps, guys? That like I say, Ms. Pram, you can see I've just guided them. I didn't give them the answers there. Okay, I just guided them on those things. Just want you to be aware of that. Okay, right. So, is there anyone else who would like a question for clarification, maybe from the assignment or some exam paper? Can okay? Okay, there's a hand. Okay, where is that hand? Who's this person? Okay. It shows a number. Okay, who is that? Is it
It's Bongiwe.
Lungiwe?
It's Bongiwe. Yes.
Bongiwe.
So I would like to know, last week we
Right.
asked for the lecturer to go or to touch on partial fractions.
Oh, okay.
Yes.
Okay. Which lecturer did you ask for?
Oh, it was last week. I can't remember her name.
Is it? Oh, that's odd. What course was it?
Maths.
For which module?
It's 15 what? Let me check. I'm not sure about the code.
But it wasn't
then-
for this module, no? It wasn't for this module?
It wasn't for this one.
Oh, okay.
Then I attend.
Okay.
Are you saying it wasn't for this one? Are you
Yeah, I'm
always the
asking
one
you.
who's
I'm asking you, yeah. Because I wasn't
Are
around
you
last
always-
week. I wasn't around last week. So I wasn't
Sure.
aware that there was someone else that took this module, that facilitated this module. So I'm not sure. Okay, be that as it may, what was your particular question that you had in mind?
I'm generally having a tough time solving partial fractions. So
Okay. No,
Yes.
then what I can do is we can look at 1 or 2 problems for you. I don't mind.
okay.
And just I think the first case. Let me just switch the light on here. The first case, there are some sections or some categories of partial fractions they want you to consider. So in your guide, and I will get the correct page for you now. I'll share the screen with you, and then we will look at some problems, maybe 2 problems at least. But I'm happy that you asked this question. So here we speak of a proper partial fraction or an improper partial fraction, okay? Or improper, not necessarily improper fraction or proper fraction, sorry. So we speak of that kind of thing. Now we know from our early encounters with fractions, we call something like this an improper fraction, okay? And something like this, we call this a proper fraction. This is a proper fraction. Can you see the screen there?
Yes.
And this is an improper fraction. So it becomes improper when the numerator is bigger than the denominator, right?
Yes.
It becomes proper when the numerator number is smaller than the denominator. You remember that from school, no? Right?
Yes.
so in the same manner, we have this notion of what we call the degree of a polynomial expression. Okay, so a polynomial. So let me just remind you about a polynomial. A polynomial can be written like this, and I'll explain these things to you now. So let me call this polynomial p of x. So where x is some unknown, okay, or some variable or indeterminate. So so this is a general polynomial of degree, what we call degree n. I'll explain that to you now. Plus, then I go on maybe a n minus 1 x to the n minus 1 plus a n x n. And here we do not assume that a n, it cannot be equal to 0. So we call this, so these a naughts that you see in a1 and a2, a n minus 1, of course, there's some terms missing in between there. And this a n that you see, those ones, we call them constant coefficients, okay? They're called constants, right? Of course, this is a polynomial in x. And the degree of this polynomial, is the highest exponent there, okay? Or the highest power there. The highest power there is x to the n, okay? That's the highest power. This is the greatest power, it's x to the n. Remember, this is the exponent, this is the base. The whole thing is called the power, okay? Right, so the degree of this polynomial is equal to n. It is the biggest exponent there, okay? For example, if you look at a quadratic polynomial, a quadratic function, let's say p of x is equal to, let's say, now I'm coming to stuff that you know about. So I'll say x squared minus 2x plus 1, say. So there we have what we call a quadratic polynomial, okay? Here, this coefficient is 1 here, this coefficient is minus 2 there, and that coefficient, well, and that constant term there is just 1, okay? The degree of this polynomial, the degree here, what is the highest exponent there?
2.
2, can you see that? Okay. So,
Yes.
and then a linear function, let's say, so we can call this p1 of x, say, and this p2 of x. Let's say we have a linear function like this, x plus 1 or 2x plus 1, say 2x plus 1. What is the degree there now?
1.
1, good, can you see that? And now, so that now that you have an understanding of what the notion of degree means in this context of polynomials, we call something of this form, we call it the following. So if you have, let's say, x squared minus 2x, I'm taking all the same examples, over 2x plus 1, say. If you have something like this and you must now resolve this into partial fractions, what you have to bear in mind, we have a term for this. We call this an improper fraction, okay? Improper. Why? Because the degree of the top one, the degree of the polynomial in the numerator is bigger than the degree in the denominator. Can you see that? Pretty much like 5 over 4 is an improper fraction. Can you see that? It's the same kind of thing. Okay? So this one has got a higher degree, and this one's degree is 1. It's a lower degree. So the degree of this one is 2, and the degree of this one is 1. Can you see that? So we call it an improper fraction. Okay? Right.
Yes.
By the same token, if we had now reversed the roles and instead of having the denominator function in the numerator, or let me just say that again, we have the denominator function now in the numerator and the numerator function in the denominator, well, now you have a proper fraction. Can you see that? This is proper.
Yeah.
By virtue of the fact that the degree of this one is 1 and the degree of this one is 2. Okay? Right. So that is important to bear in mind. Okay. Right. So now, what I'll refer you to before I start, maybe doing one or two examples, particularly on this case. Maybe for now I'll focus much on this case, and then hopefully the next time when I see, hopefully tomorrow, then I can focus on this improper case. Okay. So let's just see. So now I want to refer you to the guide. because the guide speaks of various subcases that you have to consider, okay? So initially what you will try and do is, when we deal with a proper fraction case, we will try and factorize, see if we can factorize the denominator function, okay? We'll see if we can factorize it. Sometimes it's not possible, sometimes it's possible, okay? So they explain you what you must do in each of those cases. So different scenarios arise, different situations arise, okay? You have what we call repeated linear factors. You can have a quadratic factor that's not factorizable. You can have a combination of a quadratic and linear factor. And then there are certain ways you go about this. So let me just refer to the study guide. Let me just share the study guide with you quickly. And then we look at those particular cases, and then we can do some problems. Let me just stop sharing that one and share with you the learning guide, okay? And then let me just try and find those instances. I think it's on page 60 somewhere there. I think, I suspect. It's the complex numbers. Yes. Here's it, partial fractions. Can you guys see the learning guide there on partial fractions? Can you guys see
Yes,
the learning
sir.
guide? Great. Okay, great. Okay. So I'm just going to scroll down and then we'll talk to those scenarios, okay? The scenarios I refer to. There are cases whereby in the denominator we have what we call linear factors, and then we have what we call repeated linear factors, and then we have a quadratic factor, which is not which you can't factorize, it's not factorizable. And then there are certain things you have to watch out. Then the rest becomes very easy once you follow that, okay? And I hope you guys are still familiar with long division, because we'll do that when we have improper fractions also, okay? I hope you guys are still familiar with the notion of with long division, but we'll go through that. It's not a problem. There's a case of how they do that. Probably we'll have to do one of those first. But I just want to go to the different scenarios that you'll have to consider before I start with long division, and then attempt to do one or two problems, at least at most two, I think, yeah. So let me see the different scenarios. Okay, that is a summary. It's a summary. Looking for the scenarios now. Okay. One, but it can't be there so quickly. Okay, fraction by long division. Oh, that was that. So I have to go back further. Sorry, I was ahead of you guys. I'm just looking for the scenarios, guys. Let's spell it out, and then we'll do some problems. So, right. Yes. Okay, here's it coming up. Should be now, anytime now. Sorry for that. Repeated linear factors. Okay, that's the one I referred to. And then there's this one, this case, where it's linear factors, but it's not repeated. Okay, so here are the scenario. Here is one scenario. So you have what we call a proper fraction, right? So that you have the degree of the function in the numerator is lower than the degree of the function in the denominator, okay? But now in the denominator, you have what we call a linear factor. So there are certain ways to go about that. For example, here they give you this. We can do this problem quickly, perhaps. See how they do this problem, bearing in mind what they say here, where we have what we'll do first here. We see that this is a proper fraction. I think you'll agree with that, because the degree of the numerator is smaller than the degree of the denominator, okay? Right. If this here in the denominator, the quadratic function there, if it was on top, and the linear function here on top was in the bottom, you'll have to do long division first. But of course, this is already in the proper fraction form, so we can just now apply what they say. So what they say in this problem, let's try and do it on, let me just write it down first. So it's, just get some paper, guys. So we'll resolve that. So it's 3x plus 8 divided by x squared plus 2x minus 5. What we'll do first with this problem, we'll try to factorize the denominator, okay? We'll first try to factorize x squared plus 2x minus 5 into linear factors, right? And then we'll follow these steps 3.1 up to 3.3. Okay, right. Are you guys still with me there? Are you still with me? No?
Yes, sir.
Great. And then I think what I will do is I will reserve the long division maybe for tomorrow when we get to the case where we deal with improper fractions, right? So let's try and do this problem. It's 3x plus 8 over that. And let's see how we go about to that. It's minus 35, no? Minus 35, okay. Right, let's see if we can do that. Let me just share the whiteboard with you. Right, where's the whiteboard now? Right, whiteboard, share. Share the whiteboard. Stop sharing that, share the whiteboard. Okay, great. Can you guys see the whiteboard there? Can you guys see the whiteboard?
Yes, sir.
Okay, so we have to write this. We have to, what was that question? We just have to write that into partial fractions. We have to find the partial fractions there that make up that expression. So, so there was this question. So let me call it an example because it was an example indeed. So we have to bear in mind the steps for linear factors. So 3x plus 8 over x squared plus 2x minus 35, okay? So we want to split it up as the sum of two terms first. That's what we want to do, right? So what we do first, we say, okay, we have to factorize the denominator. And I don't know if you guys still remember your factorization, but you are informed by it as follows. So we'll split up denominator into the product of two linear factors, okay? So we know that 35 is 5 times 7, right? We see the middle term is positive. So the 7 will have a positive sign. And we see that x times x is x squared. And we see that 7 minus 5 is 2. Yeah, and that's where we are, okay? That's where we are. So now, whenever you encounter a form like this, you just write it as a over x minus 7 plus b over x plus 7. And you guys can just double check whether the multiplications are fine. X times x is x squared, minus 5 times x is minus 5x, and 7 times x, 7x, 7x minus 5x is 2x, and negative 5 times positive 7 is negative 35. So everything seems fine, okay? So you need to now evaluate for you to reach this. This here that I'm circling was the sum of two fractions, two proper fractions, okay? It was the sum of two proper fractions. Now I have to establish what A and B are. That's what I have to establish, okay? Right. So this is how we do it. This is how we do it. So therefore, so what I'm going to do is I'm going to do it like this. I'm going to multiply right through on the left and on the right. I will multiply by x minus 5 times x minus and x plus 7 on the left hand side. And on the right hand side, I'm going to do exactly the same. I'm going to multiply every term on the right hand side. Every term on the right hand side, I will multiply by x minus 5 times x plus 7. Because this is an equation, so what I do on the left, I must also do on the right. Is there a hand there, guys? Is there a hand? Someone's hand is up. You can ask your question. That person can ask the question, guys. It just says
It's an
I'm
old
very.
hand, sir.
Oh, it's an old hand. Sorry. Okay, let's get some new hands then. Okay, great. Okay, guys. So because this is an equation, whatever mathematical operation I perform on the left, I must perform on the right with both those terms. Can you see that, guys? Are you happy there, right? So when I do my cancellations here, I remain on the left-hand side with 3x plus 8. And on the right-hand side, well, I've got a cancellation with x minus 5. And I've got a times x plus 7 remains there. Plus, and then for this term here, there's a cancellation with x plus 7. And then I remain with b times x minus 5. Now, there are a number of ways to solve this, okay? There are a number of ways to solve this. If I say this to you, for example, if I say this to you, suppose I say to you that 5x minus 1 is equal to ax plus b. From here, so leave that problem for now, we'll come to that one on top. Let's just look at this. From here, you can say that a is equal to 5 and b is equal to negative 1. B is the constant. And the coefficient connected to x is a, which is equal to 5. Okay? So immediately I can say, if you give me such an equation whereby you say determine a and b, if 5x minus 1 is equal to ax plus b, then I will say, well, b is a constant, minus 1 is a constant, so b has to be equal to minus 1. And a has to be equal to 5 because 5 is connected to x and a is connected to x. So that's what you conclude there. And that's the same kind of reasoning we'll apply to the problem that we're doing now, okay? There are other ways of doing it, and we can touch on that maybe tomorrow night. So why can't I raise this now? Okay, right. So this was just for purposes of demonstration, guys, okay? What we will be doing here. All right, sorry, guys. All right, maybe let me do this. Why is it not disappearing? Okay. Okay. All right, sorry for the delay, guys. So let's proceed now and see what we have as coefficients, how they connected to x, and then we equate to find a and b, because we need to find a and b. And then we'll look at what the guide says. Maybe they approached it differently, that's fine, as long as the method is correct. Okay, right, let's see quickly. So our problem is the following. That's what we have there. So let's just multiply here. So I've got ax plus 7a. I'm multiplying now, guys, plus bx minus 5b. And this is 3x plus 8. Now I'm looking for my common factor for x. So x, well, if I say a plus b, its common factor there is x. I'm combining these two here. Okay. Then my constant coefficients are 7a. My constant terms are 7a minus 5b. So clearly, based on what I just said with the problem I constructed below, you can see that a plus b is connected to x and 3 is connected to x. So clearly, a plus b is equal to 3. On the other hand, 7a minus 5b is equal to 8. That's the constant. So 7a minus 5b is equal to 8. Right? So we have two unknowns, a and b, which we need to find because we require it here. We need a and b here. That's what we need to find, okay? So we've got two equations, two linear equations, and two unknowns. So we can do that. Let's multiply the first equation by 5. So this is equation 1. This is equation 2. So I'm going to multiply the first equation by 5. Multiply equation 1 by 5. Plus 5a plus 5b is equal to 15. My second equation, I keep it. It's 7a minus 5b equal to 8. Okay. Now, I add the two equations. I add them. I add the left-hand sides and I add the right-hand sides. What do we have? 12a, 5b minus 5b is 0, and 15 plus 8 is 23. Therefore, if I divide on the left and on the right, a is equal to 23 over 12. Just check if my working is correct, guys. Okay, so what I've just done was I multiplied the first equation by 5 because I anticipated I have to cancel that b there. Okay, so I'm adding those b's. 5b plus minus 5b is 0. 15 plus 8 is 23 because I multiplied the first equation throughout by 5, right? And then I added to equation 2. And now if I want b, I can substitute a into any of the two equations here. So substitute, you get the same answer. Substitute a equal to 23 over 12 into equation 1. Into equation 1, right? So let's substitute it in equation 1. So a is 23 over 12. Let's see there, okay? So therefore, 23 over 12 plus b is equal to 3. Right. Therefore, b is equal to, what is 3? Well, 3 is 36 over 12. 3, this 3 can be written as 36 over 12 minus 23 over 12. So 36 minus 23 is 13 over 12. And there's your b. Okay? Right, so that ultimately in the final analysis, you can write 3x plus 8. You can write 3x plus 8. The final analysis, therefore, 3x plus 8, and you can double check that answer, divided by x squared plus 2x minus 35 is equal to, well, a we said is 23 over 12 over, and that linear factor in the denominator where a was, the linear factor was x minus 5 over x minus 5 plus, and then b we found it as 13 over 12, and the linear factor there from the factorization was x plus 7. So in the final analysis, you can write that, you can shift the 12 back to the denominator. You can write it as 12 times x minus 5 plus, and you can shift the 12 in the numerator to the denominator. 12 times x plus 7. And there's your partial fraction decomposition, okay? So that's what you targeted. I'm not sure who asked the question. Who asked this question again, guys?
I see, sir. Thank you very much.
What was it again? Can I just know? Is it Carol? Is it Masatsi?
It's Bongiwe, sir.
Bongiwe. Is it Bongiwe? Oh, Bongiwe, you're anonymous here, man. I can't see a name. Okay, that's why I don't know. It says 2346472 unverified. Okay. Okay, Bongiwe. So that was the instance. That was the case where you had in the denominator you factorized the quadratic factor. The quadratic factor was factorizable, and you could write it as x minus 5 times x plus 7. And then all we had to set out was evaluating a and b, which we found by solving those equations that arose there. Okay, right. And let me just see if I can share the. So I don't know, this thing is up to its stuff again. Right, I just want to find this again, guys. Sorry, my thing is acting up again. Okay, so we've got that right. We've got that right. Right. So I just want to share with you the learning guide quickly. Let's just see there where we found it. So this was the problem. Can you guys see the learning guide there?
So is there a way whereby you can check if your answers are correct or not after
Yes,
doing the whole
yes,
calculation?
yes. You can check it. There's a quick way to check it, and there's a complete way of checking it. Let me just see if we work this out correctly, guys. Okay, indeed, A was 13/12 and B was 23/12. Okay, right. I think they approached it a bit differently from mine, but it's the same answer eventually. Okay, right. And that's how they wrote down the decomposition A over X plus 7. People, let me just say, it doesn't matter where you put the X plus 7, B over X plus 7 or A over X minus 5, like I put it. It doesn't matter. In the final analysis, you'll have the correct result. Okay, the final analysis, because I had my A is 23/12 and my B is 13/12, right? My A was, for me, my B was 13/12 because I had put B, for me, I put B over X plus 7 and they put B over X minus 5. I put A as A over X minus 5 and they put A as A over X plus 7. But in the final analysis, you come down to the same result, okay? Just bear that in mind, okay? So you will see from here. And now just to come back to that question that you asked, let me stop sharing this. Let me share the whiteboard again. How to check your answer? You can do the following. You guys can see there. That's we've got it exactly the same like they did. Now, if you want to check your answer, you can use any number. Let's say. Oh, okay. Okay. Sorry. Thanks for that. People, let me just share the whiteboard with you guys. Share. Okay, great. Thanks for that whiteboard. Yeah. Okay. So this is what we found, and this is what their example also looks like in the final analysis, their answer. Okay. Now there was a question relating how can I check whether my answer is correct? Well, you can add these up and get the LCD. There's one way, okay? You can get the LCD and check whether you get this 3x, whether you get the left-hand side. You add the right-hand side, the 2 on the right-hand side, you add them and see whether you get that, okay? So let's check. Let's check our answer quickly. And then there's another way of checking, okay? So now I'm checking the right-hand side. I'm doing the right-hand side. The right-hand side is equal to. Now let me get my LCD quickly. Let me get my LCD, my lowest common denominator, my lowest common multiple, okay? Let's check that. Well, 12 times 12 is 144. I can keep my 12, but I don't need to multiply it. I keep my 12. Keep my 12. There's my 12. I have X minus 5. And I've got X plus 12. X plus 7, sorry. So I've kept these factors, multiplied them, and I kept the 12 because the factor of 12, the highest common factor of 12, or the lowest common factor of 12, sorry, is 12. Okay, so it's there. Right. So now let's do this now. How many times does this divide into the denominator? Well, that will cancel that. I'm left with X plus 7. I've got 23 times X plus 7 plus. Now I ask, how many times does this divide into here? How many times does that divide into there? Well, this will be cancelled here, and I'm left with X minus 5. So I've got 13 times X minus 5. Right? Now we check. Now let's check now. Let's multiply out the numerator now. So you've got 23x. Sorry for that, guys. So we're just checking the answer, right? There are other ways I'll show you. 23x, I'm multiplying now, guys. Plus 23 times 7, well, it's 21, 2, 16. Right? Plus 13x. And 13 times 5 is 65. And then in the denominator, I've got 12 times x minus 5, x plus 5, x plus 7, sorry. So let's add quickly the like terms. Well, this is 36x. And then 16 minus 65, what is that? What is that, guys? 60? What is this? 161 minus that? Is it 96? 96, yeah? 161 minus 65 is 96, I think. Okay, right. And I've got my 12 there. What is x minus 5 times x plus 5? It's just this here, right? So I'm multiplying that already now. X squared plus 2x, because that's how I factorized it, minus 35. So I've multiplied these two, okay? Right. Now, what is my common factor of 96 and 36? Well, I take out the 12. I've got 3x. 12 goes in there 8 times. 8 times 12 is 96. And there's my 12. And voila. I get back to my original. There's it. And this is exactly the same as this. Okay, so that's our check. That's a bit of a long way. Now, you can check it as follows. A shorter way of checking it, maybe using 1 or 2 values. You can check it as follows. So let's check again. So let's check again. Let's check again. So this is complete. This check is complete. It's done. Once you've done that, you need to check again. So let's see. Let's check 3x plus 8 over x squared plus 2x minus 35. We want to check whether this is equal to this. What did we have there? We had 23 over 12. 3 over 12 times x minus 5, I think it was. Times x minus 5. Plus, I think it was, what was it? 13 over 12 times x plus 7. Then 13 over 12 times x plus 7. So now you can use a value. Don't use a value like 5 or minus 7, because on the right-hand side, the denominators will be 0, and you can't, the division by 0 is not permissible. So you can choose any value there except x equal to 5 or x equal to minus 7. Otherwise, these won't make sense here, okay, because you'll divide by 0. So what I propose is choose x equal to 1 and see if the left-hand side is equal to the right-hand side. So let x equal to 1, say. Let x equal to 1. Substitute 1 wherever you see x. Substitute 1 wherever you see x. Substitute 1. And let's see what the left-hand side is now. So the left-hand side is equal to, let's choose that, x equal to 1. So you could have chosen 0 also. It would have been fine because it's not a problem. 0 is actually much easier to choose, okay? Let's choose x equal to 0. It's less work. When x is 0, this is 0. And I've got 8 on top on the left-hand side. And then when x is 0, this is 0, this is 0, I've got minus 35. Okay, with minus 35 in the denominator. Like I said, you could have chosen any value of x except 5 or minus 7 for obvious reasons, right? Let's check the right-hand side if x is 0. Let's check the right-hand side if x is 0. Well, right-hand side is equal to 23 over 12. We put x equal to 0 in here with minus 5. Plus over 13 over 12. So you see, I don't put it the left-hand side equal to the right-hand side immediately. I'm trying to verify the equality by virtue of just substituting some value of x that will make that thing to be defined, okay? So when x is 0 here, I've got 7. So what do I have currently? Well, I've got 23 over minus 60, and I've got 13 over 84. 13 over 84, which looks very awkward. You guys can check maybe that multiplication there. Let me just see, 13 times 7 is 91. 13 times 6 is 78. So you can possibly do this kind of thing. I'm going to be long-winded now, guys, because I can't immediately check the LCD here. But what I'm going to do is I'm going to do a multiplication. And then maybe I'll do after that I'll do a cancellation thing. Okay, so let's say let's say 60 times 84 quickly, just to get the LCD. I'm not sure if that is the lowest common denominator, but it doesn't matter. Let's just say 60 times that. So it's 24, 2, it's 50, 5,040. Okay. Then 60 goes in the 84 times minus 23. 84 goes in there 60 times 13, gives me 780. Okay. 13 goes in there 60 times, it's 780. And then, so we're just checking. People just do multiplication there, minus 23 with 84 there quickly. What do you get there? Minus 23 times 84, what do you get quickly? Those with calculators, is it, well, this one I know is 780. Okay. 180, and then minus 20 times that, and then 3 times that. It's 1932 over 5040. Remember, we want this answer. Let's see. Let's just do the subtraction there, guys, and then see. Let's do the subtraction there. It's 780 minus 1932. 1932 and minus that. Let's just see quickly, guys. Is it minus 1152? Just double check for me, guys. When I add that, yes, I get that. And 5040. Now we can say let 2 go in there, let 2 go in there. 4 can go in there 2 times, and 3, 4 can go in there 7 times, and 7. 4 goes in there 18 times. Let's say 4. 4 goes in here. 1, 2, 2, 6. Okay, let's say 4 goes in there. Let's try 4. 4 goes in there 2 times, the remainder 3. 4 goes in there 7 times, the remainder 7. 4 goes in there 18 times. Oh no, it can't be. That's wrong. Guys, just help me with this one. 4 goes into 11 2 times, remainder 3. 4 goes into 35 7 times, so 7. And then I've got this awkward thing here. Maybe I should use a bigger one. Let me just see. I know the bottom one, 4 goes in there once, 2 times 2, 6, 0. 4 goes in here 2 times, remainder 3. 4 goes in here 9. 4 goes in there 8 times, so it's 7. 4 goes in there 18. How many times does 4 go into 1152, guys? Check for me. Let's double check my steps here. I'm dividing 4 into here now. 4 goes into 11 2 times. Those guys with calculators. And then the remainder is 3. 4 goes in there 8 times. Oh yeah, 8. Remainder 3, 8. Okay, 288. Okay. So remember, we're trying to get this thing. We just substituted the value. Of course, if you have a calculator, this is very quick. Okay. How many times? What number goes into 35? What number goes? Let's try 36. Let's see 36. 36 goes into the denominator. How many times? 36 times 35, guys. Just multiply 36 times 35, and 36 goes in there. Just see if you guys get that. There's it. Okay. Right. Just double check for me, guys. I was just. Seems fine. Seems fine. Because you can say 2 goes in there 144 times, 2 goes in there 630 times, 2 goes in there, but you get the same answer. So my point was, you guys can use calculators for this. This is relatively simple, but if you have a calculator, it's quick, right? So we verified now by using an actual number, 0 in this case, and then we found the left-hand side to be minus 8 over 35. The right-hand side, we initially found it to be very uncomfortable. We had those huge numbers. And I just said, okay, I don't have time to decompose these into its prime factors. There is a way of getting that, and you can get the LCD, but I just said, let me multiply the two numbers, and I got this number. There is a way to get it actual to the LCD, and you guys will know this method where you decompose this thing into its prime factors. For example, someone would say 2 times 42. 42 is 6 times 7. 6 is 2 times 3 times 7. Okay, and then someone will say 60 is equal to 2 times 30. 30 is 15 times 2. So 2 times 30. 30 is, well, 30 is 2 times 15. So it's 2 squared times 3 times 5, I suspect. Yes, okay. And then if you want the actual LCD, all you have to do now is see the highest exponent. So if you want the LCD of 84 and 60, you decompose it into prime factors. You get the highest power of 2, which is 2 squared. Okay, 2 squared, right? And the highest power of 3 is just 3. The highest power of 5 is 5, and the highest power of 7 is 7. So that ultimately, that is the actual LCD there, which is 35 times 3 times 4, which is equal to 420. That's the actual LCD. So here it would have been easier if you put in, you put in 420. Okay, but I was just multiplying quickly in my head to get that conveniently. Okay, but it comes down to the same thing, exactly the same thing. Okay, right. So I was going to propose, rather than doing what I did, if you decompose this into its prime factors, you're just going to write here 420 as the LCD, and then say 23 goes into 420. I don't know how many times it goes in there. 420 divided by 23. I don't know. It will give you a whole number, or you can just look for some common factors there. Okay. Let me just see 84. That's 6 times 7 is 42. That's 3 is 2 squared times 3 times 7. Okay. 60 is 4 times 15. So it's 2 squared times 3 times 5 times 7 is 35 times 3, 105 times 4. 105 times 4. Yeah, it's 420. Yeah. So anyway, but the crux of the matter is we got the left-hand side equal to the right-hand side by choosing x to be 0, such that the left-hand side and the right-hand side remains defined. Okay. Of course, it would not have made sense for you to choose x equal to 5 or x equal to -7, since the right-hand side would be undefined. Okay. Right. Any other number, any other real number would do. It's not a problem. Okay. Right. Okay, guys, sorry that took a bit long. Was there any other? I'll try and bring my calculator with next time. Okay. Were there any other last questions, maybe, guys? Then, but I can, in the absence of questions, then tomorrow what I will do is I will just go into more detail with the partial fractions. And so what we looked at today was just the linear factors. Then tomorrow we can look at repeated linear factors, then the quadratic that can't be. Then we can look at a combination of the linear factor and the quadratic factor. Then we can look at a quadratic factor that you can't factorize. It's not factorizable. And then we can look at an improper fraction where you have the degree of the polynomial in the numerator is bigger than the degree of the polynomial in the denominator, and we'll use some long division. Okay. So we can look at that tomorrow. But if there are any questions, we still have another 10 minutes left. Okay. Any other questions there? Let me just check who asked this question, guys. Is that person okay now? Is that person fine?
Yes.
Because someone asked,
Thank
can
you
we
very
check it, right? I think you asked, can we check it? And then I tried to show you
Yes.
two methods, né? I tried to show you two methods. You can take your pick, okay? You can take your pick. Right. Okay. Okay. Right. Any other question, guys? Any other questions? Maybe last question, and I can just guide you rather than solving the thing in detail. Because if there are assignment questions, of course I can guide you. I'm not allowed to solve it in detail for you. Only after the fact, when the solutions were posted and you still battle to grasp the approach taken, okay? Then I can step in and maybe tell you, okay, let's solve it completely. And sometimes I may show you another method, but as long as it's legit, it's fine. And they don't specify, use this method. You can use any mathematically legitimate method. It's not a problem, okay? Right. Okay, so let me check. Some people never ask questions. There's Rachel here and Seflodi, Rachel. And there's Astro Boyson also. Any other questions from you guys? or anyone else for that matter? Tamagelo? Mpo? I'm trying to call you by name now so that I put you on the spot. Are there any questions there? Nompumelelo? I've got some names here so I can call you aloud. Okay, Patience?
Hello, hi, sorry.
Hi, Patience. Any questions there from you?
It's Nompumelelo. No, there's no questions.
No
Raised
questions. Okay, no problem. That's fine. Okay.
I think Bongiwe was the one who asked the question, who
Oh, it was
asked
Bongiwe.
to explain
Okay.
on
Checking.
complex numbers.
On complex numbers. Okay, what about complex numbers? What question was it particularly?
No, I think Bongiwe was the one who asked you to explain on it.
Okay. But
I'm
I
fine.
I didn't see the chat. Was it in the chat? Was it posted in the chat?
No, she raised her hand.
Oh, okay. Okay, Bongiwe,
Yes.
quickly, you still have 8 minutes. What was your question regarding complex numbers?
No, Nompumelelo, I didn't ask about complex
Okay.
numbers. I was asking
Okay.
about partial fractions. I was the one who asked about partial
Partial
fractions.
fractions. Okay, great. That's fine.
Now,
So we dealt with the first case, Bongiwe. We dealt with the first case, okay? The first case, we found a proper fraction, and we could factorize the denominator into two linear factors which were not the same, right? So that was the approach. And then we had to ultimately establish the values of A and B. We had to find that, okay? Which you can do in two or three different ways. So we found those values, 23/12, I think, and the other one was, what was it? 13/12, right? So we found those values. So that was for linear factors which were not repeated. So what we will encounter tomorrow is repeated linear factors. What's the approach there? And then we'll also do maybe one with a linear factor and one with a quadratic, which you can't factorize. And then ultimately, we'll look at the case where you can't factorize the quadratic in the denominator. And then maybe for the improper fractions, which we can postpone maybe to next week, we can then say we can look at long division and how to resolve the proper fraction that arises from there. Because when we employ long division, it will be to make an improper fraction a proper fraction, a constant component with a proper fraction. And then we'll use the same approach as we've done today and hopefully tomorrow. Then we'll use the same approach next week for that, okay? And of course, if Bongiwe has questions on complex numbers, that's also fine. Then we can have a look at that also briefly tomorrow. Maybe just to guide you on it also. If there's something from the assignment, it's fine. Or from some previous question paper, that's not a problem, okay? Right. Okay, so people, if there are no further compelling questions, then I think then we can meet up tomorrow again, same time.